Okay, this is section 1.3, and I'm going to be going through a bunch of these problems. We did the multiples of 3, so I'll be going through those. And there's a couple ways to look at how to do these. So this is the fourth roots. So we're looking for something that multiplies by itself 4 times to make 16. Well, if I know that 16 is 2 times 2, making 4, times 2 is 8, times 2 is 16, then there are 4 2's that multiply to make 2 multiplied 4 times will make 16, so the fourth root of 16 is simply 2. Or the other way to think of this is we have 2 to the fourth, that's the 16, and the fourth root is the 1/4 power. And so if you've got 2 to the power 4 and that to the power 1/4, when you got something, a base to a power, you multiply the powers, and you get 4 times 1/4, which is 2 to the 4/4, or 1, which is 2. So you can go either way, whichever way makes more sense to you. So on 33, we have 15, and then we're looking for the fourth root of 125. Well, 125 is 5 to the third. We're also doing the fourth root of 5, and that's in the denominator, so I can put this over 5 and take both of these to the fourth root, 1/4. Well, this reduces to 5 squared, so we get 15 times 5 squared to the 1/4, but 2 times 1/4 is 2/4. 2/4 reduces to 1/2, so I got 15 times 5 to the 1/2, or 15 and 1/2 power is the square root, because that's an understood 2 in there. Now you could have thought of it this way, 15. Both of these are under the fourth root, so you could have said, oh, I got 125 divided by 5. And so you've got 15 times the fourth root of 125 divided by 5 is just 25. And then called the 25 5 squared to the 1/4 power, and then you would have ended up there anyway. 36. So this is the square root. If there's no number there, it's understood to be 2. So we're looking for pairs of numbers. 4, or the square root of 4, is 2, or it's 2 squared, and the square root of 2 squared is 2. And the square root of y squared is y. If y is positive, if y is negative, then it's the absolute value of that number. So technically there should be an absolute value on that one, but I'm not going to be too picky on that for now. Now, 39, we have m to the 5 halves. So the half means the square root. I don't have to put the 2, I can. Of m to the 5th. And then I have the square root of 289. Now, 289 happens to be 17 times 17, I believe. I'm going to check. 7 times 7 is 49. Carry the 4. 7 times 1 is 7, 11. And 1 times 7, 7. 1 times 1, 1. And I get 289. So the square root of 17 squared is just 17. And 5 m's Well, there's a couple of pairs. Two m's comes out as a single m, and the second pair comes out as another m, making this m squared, with a square root of m still inside, and then we have a 17. Okay, 42. Probably easiest would be to reduce, but I'm going to do it differently. I'm going to say this is 4 square root of 2n. And square root, I'm looking for pairs. 16 is 4 times 4, a pair of 4s, and n squared times n squared, so a pair of n squareds. So I get 4 square root of 2n, and square root of 4 squared. Square root of 16 is 4, and square root of n squared times n squared, that's a pair of n squared that comes out as an n squared. The 4's look like they can reduce, and so I get square root of 2n over n squared. 45. I'm still looking for pairs. 50 is 2 times 25, and 25 is 5 squared. That's a pair of 5s. And y to the 8th is y to the 4th times y to the 4th. So the pair y to 4ths. So a 5 and a y to the 4th come out, and a 2 stays in. Oh, where's the next page? Oh, here it is. 48. Ooh, can't read that. I think that was q to the 3 halves. Square root there. Okay. So 3 halves is the square root of q to the 3rd. If that's what it was, I'm hoping it was. Square root of q to the 3rd. Well, that would be q square root of q squared times q. That's q to the 3rd. And there's a pair of q's, q times q. That would come out as a q, and there'd be 1 left. And the 63 is 9 times 7, and a p. 9 is 3 squared, so that comes out as a 3. And the 7 and p aren't paired up with anything, so they stay inside the square root. And so I get q and a q left inside, a 7 left inside, and a p left inside, and I can write those in any order. I get a q that comes out and a 3 that comes out. So I could write 3q times the square root of 7qp. Now, if I did it thinking more of powers, I could think of another way to think about this is q to the 3 halves is q to the 1 and 1/2, changing the 3 halves to a mixed number. And that is q times q to the 1/2, because that has an exponent of 1 plus 1/2 is 1.5. When you multiply, you add the exponents. So I get q and the square root of q, just like we saw here. We get q and the square root of q from that. And I could do similar stuff for the other part, but I think that was simple enough. Okay. 51. So I have w to the 3 halves, and from what we did here, you should recognize that that would be w times the square root of w. 1 and 1/2 are the powers, making 3 halves. 32 is 2 times 16, and 16 is 4 squared. And so we got a pair of 4s. So we got a 4 that comes out of this, and leaving a 2. And so that's what I have from the first part, minus this again is w square root of w, because it's w to the 1 and 1/2. 3 has 1 and 1/2. And 50 is 2 times 25. So that 25 has a square root. It's 5. So it comes out of the square root, and then there's a square root of 2 left inside. And now, since this part here is exactly the same as this part, we've got 4 of those critters minus 5 of those critters ends up with minus 1 of the w square root of 2w, or w times 2. 54. 147 is 3 times 49 times k to the 3rd, and we're doing the square root. Well, square root of 49 is 7. We got 3 k's multiplied, so a pair of them would come out. So I get a 7 and a k out, and I have left the 3 and 1 of the k's. Now, another way to look at this is we're doing the square root, so we're doing the half power. So we got 3 times 7 squared times k to the 3rd, all to the 1/2 power. So the 1/2, since this is all multiplication, I can distribute the power. Can't do it if it's got addition or subtraction. So I get 3 to the 1/2, 7 to the 2 times 1/2, which is 7 to the 1, and k to the 3/2. 3 to the 1/2 is the square root of 3, a 7, and this is 1 and 1/2, so that's a k, and 1/2 is the square root of k. Cleaning it up, 7k square root of 3 times square root of k. 57. We're doing square root. Square root of 81 is 9. We have an m. It's not squared, so we got a square root of m. In the denominator, we got 361, which happens to be 19 squared. So that's 19, and the square root of m squared is just a plain m. And nothing reduces there, so we're done. $60. Now we're doing cube roots, 1/3 power. 24 is 3 times 8, which is 2 to the 3rd. 8 is 2 to the 3rd. 2 times 2 is 4 times 2 is 8. And we got x to the 6th, and all that to the 1/3. third. All multiplication, so we can distribute the power. So we got 3 to the 1/3, 2 to the 3 times 1/3, which is 2 to the 1, and x to the 6/3, or x squared. So we got 2 cubed root of 3, and then outside of the cube root, an x squared. Now we got to do the second part here. 81 is 3 to the 4th times 1/3 is 4/3. X to the 6th times 1/3. And so we get 3 to the 1 and 1/3. 4/3 is 1 and 1/3. X to the 2. So we have these two added. We have x squared cube root of 3, x squared cube root of 3. Those are identical. We have 2 of them plus 3 of them, making 5 of these. Cube root of 3 times x squared. And finally, the last problem. 128, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, 64, 128. 1, 2, 3, 4, 5, 6. So this is 2 to the 7th, z to the 3, and a negative. See, 16 is 2 to the 4, z3, and subtract. After we do the cube root, so we got to do to the 1/3 power and 1/3 power, and there's a -1. So 2 to the 7/3, that's 2 to the 6/3, or 2 and 1/3. 7/3 is 2 and 1/3. So 2 to the 2, 2 to the 1/3, z to the 1. Minus a minus, so that's plus 2 to the 4/3, which is 2 to the 1 and 2 to the 1/3, and z to the 1. So we got the cube root of 2 times z, cube root of 2 times z. So this is identical to this. And we got 2 squared of 4 plus 2 is 6 of the what do I say here? We got 6 of the cube root of 2 and a z. I can put the z in there. There we go.